So Wednesday last week we talked about graphing logarithmic functions. And it says you can use the inverse relationship between exponential and logarithmic functions to graph logarithmic functions. The one thing we know is because exponential and log functions are inverses of each other, this is the graph of the exponential. The logarithmic graph is going to be the reflection of that over this dotted line, which is y equals x. Now what we can do is much more difficult to find an ordered pair for a log function rather than the exponential, but we can use the inverse rule to kind of help us. What we talked about is if you have something that's in the form y equals b to the x, that would be exponential. Its inverse would be y equals log base b of x. And that's how your inverses are related. Well, we can go in this order, and that can actually help us get an ordered pair that we can graph. For example, if you look down here, if we have y equals log base 3 of x, what I would do is I would write the inverse, which is going to be y equals 3 to the x. I would make my xy table using negative 1, 0, and 1 for that equation. So when x is a negative 1, y will be 1/3. When x is a 0, y will be 1. And when x is 1, y will be 3. Well, because of the inverse relation between exponential and log functions, using that table, I can get my xy table for my log function by just switching the columns. These points would graph this equation. These points would graph my log equation. So I'm going to make my xy table based on the exponential function, and then I'm just going to switch my columns. These points I can graph, and that will be the graph of the log function. So at 1/3 I should be down at negative 1. At 1 I should be at 0, and at 3 I should be at 1. And you get this curve kind of like this, and the graph will skim along the y-axis there. When we graphed exponential functions, the horizontal axis was your asymptote, kind of like that invisible barrier. When you do the reflection, that causes that horizontal asymptote to become a vertical asymptote. And so that's why a log function will just kind of skim along the y-axis. If you look at an equation like this is similar to when we talked about x plus h and then plus k. Those terms really just means that our graph is going to be translated. And for this one, this would be moving to the left 3 and up 1. Well, what I would do is I would focus on this part of the equation, y equals log base 2 of x. Write the inverse, which will be y equals 2 to the x, and make my ordered pair. Well, based on that, it would be 1/2, 1, and 2. My log function, which was this, will go through the points 1/2, 1, 2, negative 1, 0, 1. These are the ordered pairs for that part of it. So I would plot those first. I'm not actually going to connect those because I still need to, now that I have my starter points, move those to the left 3 and up 1. And so this would be the translated function.